This is Euclid Book 6, Proposition number 28, Part 1. Okay, there will be two parts to this. And it says, to a given straight line, and we're going to talk about that in just a second, to apply a parallelogram equal to a given rectilineal figure and deficient by a parallelogramic figure similar to a given one. Thus, the given rectilineal figure must not be greater than the parallelogram described on the half of the straight line and similar to the defect. Wow, you talk about a long proof. This is why it's been taking me such a long time to get this up here. I'm going to do the best I can on this, and we're just going to have to wing it. Alright? It says, let AB be the given straight line. Well, here's AB, and there's the given straight line. Okay? C, the given rectilineal figure which the figure applied to AB is required to be equal. So we're going to make a figure on this straight line here that's going to have the same area as this one right here. Okay? Alright, so let me read this again. Let AB be the given straight line, which I already showed you. C, the given rectilineal figure to which the figure to be applied to AB is required to be equal, not being greater than the parallelogram described on the half of AB and similar to the defect. Okay? Now, and D, the parallelogram to which the defect is required to be similar. Now, this is going to be the defect here, and we're going to talk about that in a second, and it has to be similar to D right down here. Okay. Thus it is required to apply to the given straight line AB a parallelogram equal to the given rectilineal figure C and deficient by a parallelogramic figure which is similar to D. So we have to apply on AB an area that is equal to C, but is deficient by an area which is similar to D. Wow. Let AB be bisected at point E. AB is bisected at point E. Okay. And in case you guys don't remember what bisection means, that means that this line is AB has now been drawn. AB is now in two equal parts, AE and EB. AE is the same length as EB. That's what that means. And on EB, let EBFG be described. Okay, EBFG is now described right here. And it is similar to, and it's similar and similarly situated to D. So this right here is similar and similarly situated to D right here. Okay? And this is by Euclid Book 6, Proposition number 18, and you can go back to that video if you want to. Let the parallelogram AG be completed. Here's AG. What they're talking about here is AEGH. This parallelogram right here. AEGH. Got it. If then AG is equal in area to C, if this is equal in area to C, that which is enjoined will have been done. For there has been applied to the given straight line AB the parallelogram AG, AEGH, this parallelogram right here. And this parallelogram right here is equal to rectilineal, this one right here is going to be equal to the rectilineal figure C. Okay? And it's going to be deficient by a parallelogramic figure, GB, which is similar to D. GB is similar to D. Okay? Alright. Now, you say, well, how am I going to figure out the area of C to make sure it's equal to this? Well, what you can do is you can draw a straight line down here. You can figure out the area inside of this, and the area inside of this triangle, because if you draw a line right here, you're going to have a rectangle and a triangle. You figure out the area of the rectangle, you figure out the area of the triangle, and guess what's going to happen? You add those two together and it'll become that. And that's how you're going to figure that part out. Okay? Now, you could do it another way, and I'm not going to go into that tonight. One of these days we're going to show you how to do that too. But basically, like I said, if you figure out the area of this rectangle and that triangle and add them together, you'll get this. Alright, and yes, there will be a second part to this proof. I will tell you more in a future video. Stay tuned.